Okay, the last topic of the course will be the final framework layer, the final countdown to service frameworks and packaged apps. So we'll talk about some of the common services in Android's application framework layer. And you use these services extensively when you develop and run Android apps. Whether you use them directly or not is another story, but they're being used under the hood on your behalf. And you rarely would ever program one of these things, but they are in use. And then we'll also talk about some of the common apps, and I don't have to go into too much detail here because you probably know many of these things better than I do. Actually, it's pretty funny. My 11-year-old son has been playing around with a feature in his school. They have Chrome laptops, and they're having fun playing around with like Excel graphics stuff, where you can enter in names and values in a spreadsheet, and then you can make graphs of things. So he's like totally into graphing stuff. It's really funny. So he knows way more about that than I probably ever did, certainly when I was 11, that's for sure. And you, of course, use these things all the time. So the application framework layer, which is actually kind of a goofy name because it's really application frameworks with a plural, provides apps with capabilities and various information they need in order to do their thing. So here are some of the things that the services provided in the application framework layer do. They give you access to hardware and OS kernel capabilities, but in a nice Java-centric way as opposed to a low-level C way. Most of these services run continuously while the system is up and booted. So once the system boots, a bunch of these services start. Some of them might start on demand, but I think most of them are just running all the time. And the control flow, of course, here is all driven by callbacks, right? So this is just like the framework stuff we talked about before. That's why it's the application framework layer, because it's written as a whole bunch of different frameworks. And by and large, the services are written with Java veneer, although there's a lot of C and C++ code in some places. And some of the code that's even Java written, if you look at it, looks like C code. It's funny, they wrote it in a very C-centric way, even though it's got the Java syntax. You can access many or all of these system services via something called the get system service method, which is available in the activity or other context. So the activity context or just the context. And you can ask for different kinds of things. You can ask, say, get me the location service, get me the download service, get me the Windows service, get me the activity service, and so on and so forth. These are things you can get out of get system service by passing in these strings. And then you can use this stuff to write apps in a more productive way, because you don't have to do all that stuff. You don't have to write the code to manage location awareness. You don't have to write the code that starts telephone calls. You don't have to write the code that's going to send SMS and MMS messages back and forth. The other thing that these service implementations do is they implement all kinds of frameworks, all kinds of patterns. They also implement frameworks, but they implement a bunch of patterns. And they implement patterns like broker and proxy and frameworks that implement these things, or binder, hammer, async, task, and so on. And so if you study patterns like the broker pattern, which appeared in the so-called POSA 1 book, you'll see that the elements in the pattern, which were documented in the mid-90s, but came from much earlier times, are actually easily mapped into the API abstractions and component relations that you'll find with the frameworks in Android. So this is basically the broker pattern mapped onto Android with proxies and stubs and parcels and all this other good stuff, so that a client can invoke a method in one address space, have the broker turn the method call into a message, shove it across the backplane of the device to a server where it's converted, the message is converted back into a method call on some kind of service, like a bound service. We'll go into the details of that next semester, but that's really cool because it shows how people building Android leveraged all these common patterns that they'd had for decades. So you don't have to reinvent the wheel, and more importantly, you don't have to reinvent the wheel in a bad way, right? Like a square wheel. Plenty of people reinvent the wheel, but they make it a bad wheel, so that's even worse. The system services that Android provides, like all the stuff here, we'll talk more about them in a second, are all coordinated by something called a service manager. And that's what's known as a super server. It's a server of servers that ensures that the services are started, and if for some odd reason they crash, that they're restarted throughout the lifetime of an Android device. So in other words, they want to always be running. It's like a watchdog, if you will. This particular thing, the service manager, is started when the Android Linux kernel boots. It's part of the init process that gets everything up and running. So you can see you have a service manager with all these services running in it, and then there's also this Zygote capability, which I mentioned before, which is used to speed up the starting of the launching of apps by pre-loading all the libraries into them. The service manager basically provides sort of a directory service, if you will, a super service, meta service, that lets you find out what services are available on your device. So here are some of the services. You can't quite see that, but it gives you a place to go find more information about that. I'll fix that in the slides I put out later. The activity manager, very, very important service. It's going to control access to the components that are part of the system, where components are activities, services, application-oriented services, and broadcast receivers. And every Android app is built out of activities, services, and broadcast receivers. And there's actually a declarative way of specifying what components are available in an app by using something called the Android manifest file. And we'll talk more about that next time as well. But that's a really important service. It's quite fascinating to read the code. It's written in a very C-like way, very, very complicated, thousands and thousands of lines long. There's also something called the download manager, which handles long-running HTTP downloads that are stored to a particular file. So you can have this download stuff on your behalf rather than having to write a downloader yourself. There's a location manager that keeps track of where the phone is. You can imagine why that would be very useful for things like maps and other navigation aids, or just location-aware services. When you say find the nearest Smoothie King, it'll find it for you, right? Because it knows where you are. It's kind of geofencing, as it's called. There's a notification manager that's used to inform the user of the phone when something's happening in the background that they might care about, like battery running low, or you've got mail, or new messages that have come in. And if you look at your Android device, you see these little badges on a lot of the apps. It'll say things like, you've got 4 new messages on Facebook or whatever, right? So that's how you get notified, various ways to do that. There's something called the package manager, and that's what's used to download these Android package kits, APK files, and everything that's available on the Play Store. When you build an app, it ends up being an APK package, and that's what gets downloaded from the Play Store. And the package manager is responsible for knowing how to parse the contents of the package where your app is, and then putting it in the right place on the phone so you can launch it. And it also registers the components of the app that are publicly exposed with the activity manager, so it knows how to get access to them. Obviously, one of the most important things we have in a phone is the phone, and so the telephony manager is what's used to actually provide access to the features of the underlying cellular radio, and so it knows how to start calls and drop calls and manage calls and switch calls and merge calls and all that kind of good stuff. There's a window manager, also important. Android's window manager has gotten a lot more powerful over time. You might or might not know this, but you can now actually have multiple windows open on your device. I don't really use that a whole lot because it's just not big enough to make it worthwhile, but you can actually resize many windows now and have multiple screens open at the same time, if you want to. It's probably overkill, but it's possible. Oh, by the way, the window manager is the thing that talks to your application main activity using the Unix domain socket stuff we talked about before. So the window manager keeps track of your touching stuff on the screen, and then it sends those touch events to the appropriate app and the activity that is currently got focus, so it knows how it can process it gets the events to process. And there are lots and lots and lots and lots more services. Probably think there's something like 30 of them. And if you run your Android debugger, you can actually go in and find out what's running, or your task manager. Common apps, again, this is going to be a lightning fast discussion because there's nothing really surprising here. So you got browsers. You can look at the source code for the Android browser. Of course, many systems, many Android devices now come with their own custom browsers like Chrome, or I believe there's one on the Samsung. It's called Internet, which is not the stock version. If you get a stock Android device, like I think the Pixel might be one, or it used to be the Nexus, then the version that you'll see there is actually the open source version that you get with the Android open source code release, AOSP. And really interesting to look at how the browser works. Very complicated piece of code. Uses WebKit, among other things. Uses lots of stuff that we'll talk about next semester. Email, obviously to send and receive email. Camera, uses all the HAL stuff we talked about earlier to interact with the low-level image buffers and surface managers and so on for encoding images and videos digitally. SMS, MMS, this also uses some low-level things we've discussed, stuff like content providers and SQLite in order to keep track of your messages so you can sequence them and thread them and reply to them and so on and so forth. And that also has not just an application activity portion, but also a service portion to manage the asynchronous reception and transmission of these messages in the background. There's a calendar, actually various calendars. There's a Google Calendar. There's a calendar that typically comes with a phone, keeps track of your appointments. Contacts, obviously keeps track of who your friends and family are. And then, of course, the phone. We use that all the time. And I don't know, has anybody here ever used Skype or WhatsApp? So I've discovered through some painful trial and error that WhatsApp seems to work way better than Skype. I have no idea why, at least on my Android device with a cellular connection. For some reason, Skype is really flaky, but WhatsApp has got great clarity. Maybe because it's not as widely used, whereas Skype is very widely used, so it may be overloaded. Obviously, all kinds of music stuff, and there's special features of music, like you can play music in the background, so even if you navigate away from the activity, it'll still keep playing. And the way it does that under the hood is it uses a music service. So services are things that can run in the background even if there is no activity open to them, or open to access them at any given point in time, etc. Right? So there's lots more stuff. So this is just a listing of some of the source code in the packages apps directory in Android. You can see there's all kinds of stuff. And this, again, is just the tip of the iceberg, right? Any given Android phone, unless it's a pure Android phone, is going to have lots and lots more apps, some of which are useful, some of which are not. And you probably download your own apps, right? So you've got even more things there. Most Android apps are written in Java, although increasingly they're also written in Kotlin. And a bunch of them come prepackaged with the Android source code release. There's also a pile of apps that Google releases that are not available in open source form. You can be daring and try to reverse engineer them by using some kind of bytecode decompiler. And if you do that, you will typically find for many of them that the code itself has been obfuscated. So if you take a look at the source code for Gmail, or you take a look at the source code for, or rather, if you try to reverse engineer the bytecode for Gmail or Google Maps, you'll find that they've changed all the names of the methods to like A, B, A1, A3, just random gobbledygook. So you really can't figure out what the heck is going on. And that's, of course, by design. And that's basically the end. So this is really sort of just for your edification. A serious discussion of these topics would require us to look at all the source code in much greater detail than we have time now.